So this video is going to give you a brief, intuitive introduction to the idea of determinism and non-determinism. So no, we aren't worried about whether or not the universe is deterministic or has free will. What we're talking about is determinism and non-determinism as ways of describing computation. So first, some definitions. An algorithm or a procedure is deterministic if its behavior is exactly the same every time we use it on a particular input. So if we give some method a particular input, then the way in which it computes its solution will always be fixed. Then that method is deterministic. If, however, the method has a number of choices which it may make in some arbitrary or non-specified way, then that method becomes non-deterministic. An example will hopefully make the idea a little bit clearer. Let's go back to our relation that we talked about before, the relation of people to dessert foods and whether or not the person likes a particular food. Our problem might be that we want to be given a person as an input, so some element of big A, and our procedure has to find something in the B set that they like. So given some element of A, find an element of B such that the pair AB is in the likes relation. A deterministic method would always give you the same answer when you gave Dave or Sarah. Or if you, let's say we expanded the definition of the problem to give us all of the solutions, all of the foods that they like, it would give them back to us in the same order and go through. However, we don't, in this particular definition of the problem, we don't particularly care about which answer we get. We just want an answer, and we don't care how the method goes through and finds the answer. So we could, in theory, envision the idea of a procedure which looks at the possible choices and then just arbitrarily picks one. Maybe we might consider a method that does it probabilistically, or we might consider a method that does all of its options in parallel and then simply returns one. Or we might think of a deterministic method that goes through in a fixed exact way and picks its solution. So you can see here, so a deterministic method will always give us the same answer because given a particular input, its procedure is going to be exactly specified. That's a lot more like what you would get if you were typically hand programming yourself an option. However, a non-deterministic method may go about arbitrarily. It might check things all in order, or it might simply roll a dice and pick some random number that lets it end up choosing a different option. We can model that idea of something which can go through and pick through a series of options by talking about a choose method. So some method which we give it a series of options and it will give us back some choice in those options. If we had a method that did that, so we gave it a series of possibilities and it simply returned one and we didn't care how it picked it, then we could model the solution to the problem we had before as simply choose some element of B, then if A and B is in likes, return yes, because we've found something that is in there. In fact, actually we should return B, and otherwise loop back and choose something else in the set B minus that option. Or even we could simply model our idea as choose an element from B such that this is true, and then we return that choice. If we've defined our problem this way, then depending how choose works will depend whether our method is deterministic or non-deterministic. If choose always goes through a particular way and say always checks for them in linear order and returns the first one, then we'll have a deterministic solution. However, if choose is somehow able to go through things in parallel, then we would have something non-deterministic. Or if choose behaved randomly each time, giving us a different answer for the same input each time we called it, then we would overall have a non-deterministic solver for the likes problem. We could even imagine if we repeatedly called choose to build up a set or a list of valid solutions to the likes problem. The first time we might choose one of a few options, and then after we've made that choice we might choose from the remaining options in each of these cases. And we can see how, depending on the way we model our problem with choose, we may end up with these big branching trees of possible decisions all going down in parallel. A deterministic method will have one fixed path that it always follows through that tree. A non-deterministic method, we won't know which way it goes through. So hopefully what you've got from this is just the first taste of the idea of determinism and non-determinism. So this concept will come back again and again throughout this course, particularly in the next week or so. We're going to introduce finite state machines, and we're going to talk about deterministic and non-deterministic finite state machines, and how we will model the idea of whether or not they answer yes to a certain question. We've also talked about the idea of a choose function and how we can use that to model a solution to a problem without explicitly tackling the determinism issue, and how, depending how we talk about our choose function, we may end up with something that is deterministic or non-deterministic.